Expression for fringe width. Here, this is single source, and here S1 and S2 are two slits. They are created from source S, and this is position of screen. And the rays from S1 and S2 meet at point P, and this distance is D, and separation between S1 and S2 is small d, and point P is at distance x from point O. And in this diagram, these peaks indicate a bright fringe, and here these points indicate the position of dark fringe. Here, bright fringe is denoted as B1, the center of bright fringe, and dark is denoted as D1. Here, similarly, this is D1, this is B1, then this is D2, and here, this line indicates intensity. Now, let's see the expression. So here we have to find out the path difference between S2P and S1P. So for the point P, path difference P equals, it will be S2P minus S1P. So first we consider triangle S1AP and then S2BP, both are right angled. So Pythagoras theorem can be applied, and we can get the values. So let's find out S2P square minus S1P square. So if we consider S2P square, that will be S2B square, that is equal to D square, plus BP square. BP is equal to, this distance is D, this is midpoint. So this OB will be D by 2 and this is X. So we can say it will be X plus D by 2 whole square minus S1P square, that is D square, means S1A D square, plus this distance is X and this AD is D by 2. So this will become X minus D by 2 whole square. Now, if we open the bracket, so what do we get? It will be D square plus X square plus D square by 4 plus 2XD by 2 minus D square minus X square plus 2XD by 2. So D square will cancel out, X square will cancel out, and D plus one more term, D square by 4. This will not be plus, this will be minus, this will also get cancelled. So we will be left with 2XD. Now, if we factorize this S2P square minus S1P square, so that will be S2P plus S1P times S2P minus S1P equal to 2XD. Here we make some assumptions. We assume that S2P is roughly equal to S1P is roughly equal to capital D. Capital D is the separation, this separation. Now, so this will become 2D times S2P minus S1P equal to 2XD, which gives S2P minus S1P equal to X small d divided by capital D. So this is equal to path difference. Now, position of bright fringes. So to get position of bright fringes, path difference P must be integral multiple of n lambda. So P will be equal to n lambda, but P equal to xd upon d must be equal to n lambda. So from here we get x equal to n lambda times capital D divided by small d. Here n can be 1, 2, 3, etc. Now, if we put n equal to 0, then we will get x equal to 0, which will be the position of central bright fringe. And then x equal to, if we write n equal to 1, then we will get x equal to lambda d upon d, which will be the position of first bright fringe on both the side of the central bright fringe, that is point O. So let's find out, let's generalize it. Let's write it like xn equal to n lambda d divided by d. And now we find the difference between two successive fringes. So let's write it xn minus 1, which will be equal to fringe width. Suppose this is beta. So this will be equal to here n lambda d divided by small d minus n minus 1 lambda d divided by small d. So this will give, if we open the bracket, so we will get lambda d upon small d. So we can say that fringe width equal to lambda d upon small d. Now we consider same thing for dark fringes. So for dark fringes, path difference so we are going to consider dark fringes. So for dark fringes, path difference must be equal to P, which we have got as xd divided by capital D. That must be equal to 2n minus 1 into lambda by 2. From where we can get the value of xn. So suppose we write it as xn dash, this x, then it will become 2n minus 1 times capital D lambda divided by 2 small d. Now, we find the fringe width in this case. So we take difference between two successive fringes. So xn dash minus xn minus 1 dash. That will be 2n minus 1 d lambda by 2d minus. Here we replace n by n minus 1. So it will become 2 n minus 1 times capital D lambda divided by 2d. So this will give lambda d divided by small d, which is beta. So whether we calculate it in case of bright fringes or dark fringes, fringe width remains same, and that is clear from here also. So difference between two dark fringes will be equal to fringe width, or distance between two bright fringes will be the fringe width. So we have got final expression for fringe width beta equal to lambda d divided by small d. Suppose we want to find out angular width. So angular width is equal to beta divided by capital D. So that will be equal to lambda upon small d. Now, if this apparatus is put in a liquid of refractive index mu, in that case, fringe width beta dash equal to beta divided by mu, or 1 upon mu times lambda d divided by d. So this is final discussion. Thank you for watching.